Here's our final question today. A plane whose airspeed is 200 kilometers per hour heads due north. A 100 kilometer per hour northeast wind comes from so that means it comes from the northeast, begins to blow. What is the resulting velocity of the plane relative to the ground? So it's asking a resulting velocity, so that's, remember that is a vector, so we want both the magnitude and direction of the plane. So sometimes it's easier, if you're having a tough time drawing these, try drawing the individual vectors. Okay? And always keep in mind that, are you given the initial vectors that are being added together, or are you given the resultant one? So in this case, we're given the initial vectors. We're given that some plane is traveling north, or its heading is north, but then 100 kilometers per hour northeast wind comes from the direction, so it's going to change its direction. So here's our first vector. So we have a vector that's traveling north. This represents the plane. Okay. Velocity of the plane relative to the air. And we also know that there's going to be some wind blowing from the northeast. So here's north, there's east. So northeast is somewhere over there. It was blowing from the northeast. So we have a second vector that looks something like that. And that's the velocity of the air relative to the ground. So these two vectors, when combined together, will result in our overall resultant vector. So let's draw them. Let's draw it again. So I'm going to draw, here's VPA. That's 200 kilometers per hour. And the wind is blowing in this direction. The angle of 45 degrees. And this is 100 kilometers per hour. So our resultant vector is so initially the plane is facing this direction. Okay. But it's going to be pushed off course by this wind. So we need to be careful with these questions coming up. They're not necessarily 90 degrees. So you cannot just simply go ahead and use, oh, that 200 looks like a 90 degree. Like, oh, it might be, it might not be. Okay. So it looks like, so you can't just do 200 squared minus 100 squared and be done. So we either have to use component method, or we can start using our sine law and cosine laws. So what you may remember is that if we're given some triangle, ABC, with angles A, B, and C, so we use capitals for the angles and lowercase for the lengths. We can say that sine A over A is equal to sine B over B is equal to sine C over C. The other one is, we can say that C squared is equal to A squared plus B squared minus 2AB cos C. We'll see more of that next day though. So today we're actually going to solve this using the component method, which we've done so much of already. So I'm going to draw a little table. We have X and we have Y. So we have VPA and we have VAG. So the plane relative to the air, and we have the air relative to the ground. And when we combine those together, we're going to find out what direction would someone on the ground view the plane to be traveling. So the velocity of the plane relative to someone on the ground that was watching this. So you see that that is this green line that I drew in. So VPA. So we look at our picture, it's only in that north direction, so it has no x component. So you're going to write down that 0 kilometers per hour. In the y direction, though, we have 200 kilometers per hour. Because it's a 45-degree triangle, we know it says 100 cos 45 degrees. And that comes out to 70.7. And because it's a right-angled triangle, we know the other one's also 70.7. Before we move on, though, let's just make sure we get our positive and negative signs correct. So, up and to the right we consider as positive, down to left as negative. So this is both down and to left. So I'm going to put in a negative sign and a negative sign. So my resultant vector is going to be negative 70.7 kilometers per hour in the x direction. And when I subtract those two, I get 129. Right, 129. Let's get it more exact. 29.3 kilometers per hour in the y direction. So I draw those components. We know this value is 70.7. This is 129.3. And I can use Pythagoras. So you get V PG comes out to be a squared plus b squared square root. You get 147 kilometers per hour. And I do inverse tan, 129.3 over 70.7, get 61.3 degrees north of the west direction. And that is our final answer.